The question that I have is, what are different types of friction? Let's start with what is called the dry friction. So considering the sliding block model one more time, the dry friction is the friction between the block and the flat surface when the contact surface is dry. In other words, there is no fluid in here, and therefore the contact surface between the block and the flat surface is unlubricated. So this is the kind that we're going to consider in this course. The second kind is called the fluid friction. This is the friction anytime you have a fluid involved at the contact surface. This could happen in a couple of different ways. For example, let's say we have fluid moving over a horizontal flat solid surface, right, with a certain velocity v. When you take a course on fluids, you will learn that this velocity v is not constant across the height of the fluid here. It's actually zero right here at the interface between the fluid and the solid surface. The velocity increases as you go up, typically linearly. So you have the maximum velocity at the surface of the fluid. Supposing, say, I'm going to come in here and section the fluid along a horizontal plane like this and see what kind of forces I have at the interface between the top and the bottom layers. You're going to see that there is a shear force at this interface. So this shear force comes about because this top fluid layer moves relative to the bottom fluid layer. So what do we have at this interface? Well, the molecules of the same fluid, right? The attractive forces between these molecules, like we talked about in another video, resist this relative motion. So this force at the interface between the top layer and the bottom layer is what we are talking about here. This is our frictional force. In fluid mechanics, we quantify this in terms of what is known as the viscosity. Another example where the fluid friction plays a role is at the interface between the block and the flat surface when the contact surface is lubricated. We know from our real life experience that if you put water at the interface, the change in the frictional force is not going to be much, right? On the other hand, if you put something like grease, the frictional force is going to change significantly. In other words, the viscosity of the fluid that we put at the interface makes a difference on the frictional force. The third type of friction is what is called the skin friction. This idea of skin friction is basically a problem-oriented classification. The skin friction develops on the surface of a solid body either because of a relative motion between the solid body and a fluid surrounding the solid body, like in this first case, or between this body and another solid material that surrounds that body, like in the second case. In the first example here, we have a moving truck. This moving truck produces a relative motion between its surface and the surrounding air, right? And that relative motion produces a frictional force resisting the motion of the truck called drag force. Air is a fluid. You will learn this in your fluids course. So you could think of this as a fluid friction, because this friction originates from the relative motion between air, which is a fluid, in contact with the solid surface of the truck. In the second example, we have what is called a foundation problem that is part of civil engineering. Civil engineers design not only structures such as bridges and buildings that we see with our eye, they also have to design what are called foundations to support these structures, right? One type of foundation is called the pile foundation. So here we have a number of piles put together in what is called a pile group in order to support a column load that comes from either a building or a bridge, right? Piles are basically long cylindrical rods that are driven into the soil before you put the load on it, the column load on it. As soon as you put the column load on it, there's going to be relative motion between the piles and the surrounding soil, and this relative motion is going to produce a frictional force. So this frictional force is the skin friction on the piles. When the soil surrounding the piles is completely dry, this frictional force comes about because the relative motion between solid particles, the soil particles in the pile, right? So this is a solid on solid friction. But oftentimes the soil is saturated in water because of the groundwater, right? But it turns out that the water doesn't have too much influence on the frictional characteristics of the interface between the pile and the soil. Once again, this is because the water has very small viscosity relative to fluids like grease or oil or something like that, right? Anyway, this is another example where you have skin friction in play. Let's also talk about the difference between sliding friction and rolling friction. This is looking at friction from a different angle. So far in our discussions, we've been referring to sliding friction, right? Considering the sliding block model one more time, as we keep increasing the horizontal force P, this resisting frictional force F increases, and at some point it reaches its maximum value, right? And that's when the block is going to start sliding on the surface, right? And this is what is called the sliding friction. Now let's talk about rolling friction. Supposing, say, we have a circular wheel placed on a flat surface like this. Supposing, say, you hold it at the top of the wheel, pull it sideways with the force P, and try to roll the wheel. If we increase the force P gradually, we're going to find that it's going to take a certain amount of force before the wheel starts to roll. The resisting force here is what is called the rolling friction. Supposing, say, you applied enough force, created an initial velocity, and took your hand off. What's going to happen? Is the wheel going to keep rolling indefinitely? No, the wheel is going to come to a stop after traveling a certain distance. Assuming that the resistance coming from the relative motion between the air and the solid, the wheel, is negligible, that is, assuming that the drag force is negligible, right? The force that made the wheel come to a stop is the rolling friction. The rolling frictional force is the one that produced deceleration of the wheel, and eventually the wheel comes to a stop. So it turns out that the rolling friction is usually much smaller than the sliding friction. And in this course, we are not going to focus on the rolling friction. So we will only consider sliding friction in the problems that we will try to solve here.